Howdy, we're the Endeavor team that serves Madisonville, Texas. We're comprised of four students, two urban planning students, Colby Newsome and Tristan Zepeda, and two computer science students, Tania Sebastian and Alicia Yong, as well as two graduate advisors, Patricia Michel and Tristan Lyons.
Hi, my name is Alicia, and I'm going to start off by talking to you about the background of Madisonville. So Madisonville is predominantly a cattle ranch community with a makeup of about less than 5,000 residents, and their median household income as of 2019 is about 50K. So the problem we're trying to tackle is Madisonville's completely outdated water infrastructure. For a couple of years now, they have been unable to sustain itself, specifically in regards to pipe leakages and pipe breaks, as well as flooding in their water treatment plant. And so, because of the drainage issues, it results in, as I said before, flooding of the water treatment plant. So our problem statement is to tackle this. So an overview of our solutions. So as Christian has mentioned, our team makes up of two comp sci and two urban planning majors. So part one of our solution is the comp sci's perspective. So we are trying to tackle Madisonville's issues of outdated water pipeline system through machine learning to predict the size and location of the water pipe leaks. And then part two would be urban planners' mission to create an environmentally friendly solution to the town flooding water treatment plant, as well as providing a vision for the city's future. And as I mentioned before, our computer science focus on machine learning. Our goal is to reduce damage and financial impact of pipe leakages by predicting them before they happen through a machine learning algorithm. And since Madisonville currently doesn't have that much data on their pipelines and their water infrastructure, we have tested and trained this algorithm through a sample data set that we found thanks to Dr. Shaspari. And so now I'm going to pass on to Tania to look further onto our computer science focus.
Hi everyone, I'm Tania, and I'll be talking a little more in depth about what we've done with machine learning and predicting these pipe leakages. So the data that we've collected for our algorithm to predict where pipe leakages will occur is in the form of pressure trace measurements with their resulting leak locations and leak size. Our data set has 3,000 samples, and the input to our algorithm is a time series of pressure trace measurements, and the output is the resulting size and location of a pipe leak. On the right is a plot of a sample of one of our data pressure inputs, and you can kind of see that is the input for our algorithm. So from our input data, we were able to find the mean standard deviation, average increase and average decrease in pressure to better correlate the input data with the location and size of pipe leaks. We then were able to train and test this data on linear regression machine learning models to determine that there was indeed a strong negative correlation between pressure changes in pipes and leak size, and that leak size could be relatively accurately predicted with machine learning as represented by the graph on the bottom right. However, we also did find that the location was not as clear and easy to predict as represented by the graph on the top right. But in the end, we were able to find some distinct results that made sense of our data. Although we were able to get successful results from our data in machine learning experiments, this project is still ongoing, and we hope that future teams will be able to build off our existing work and continue to provide solutions. Some plans that future students may expand on is working with Madisonville to gather pressure trace data that can then be used in the algorithms that we used a sample data set for, and testing our machine learning solution on data from other data from Madisonville's pipes, and implementing an artificial neural network leak prediction that we were not able to do yet this semester. I will now pass it off to urban planning to talk about what they've done.
So from the urban planning perspective, we were focusing on two issues: the flooding at the water treatment plant and its aging infrastructure. So these issues can be fixed through a variety of solutions. We're focusing on integrating green infrastructure such as bioswales and rain gardens as a low-cost, high-function aesthetic solution. The green infrastructure will remedy the flooding by adding a natural water retention system and lowering the stress on the current gray infrastructure. Combining this with a comprehensive plan that includes a capital improvements plan for the gray infrastructure, and the issues should fade away in 5 to 10 years, and the city's infrastructure will have a sustainable future. So bioswales, as explained by the Natural Resources Conservation Service, or stormwater runoff conveyance systems that provide an alternative to storm sewers. They can absorb low flows or carry runoff from heavy rains to storm sewer inlets or directly to surface waters. Bioswales improve water quality by infiltrating the first flush of stormwater runoff and filtering the large storm flows they convey. Bioswales are becoming increasingly popular in today's urban design, and the National Association of City Transportation Officials state that bioswales are the most effective type of green infrastructure facility in slowing runoff velocity and cleansing water while recharging the underlying ground table. Below are some images of green infrastructure in various parts of the county. Our proposal would be to take Madisonville's current streetscape in its neighborhoods, which currently look like the image on the left, and transform them into looking like the image on the right. The new streetscape would provide improved water retention, add to the community's biodiversity, and give an aesthetically pleasing view to the eye. Bioswales are low maintenance when planted with native species of plants and low cost to implement and maintain.
So the other part of our urban planning perspective is the preliminary comprehensive plan. And we want to use this as a vision for the city to reference, and we want them to have input, like we want like a diverse range of input in order to reform and revise the preliminary plan. But we want to provide them with the reference of ideas to use, ideas ranging from low cost, small scale ideas to larger phased out plans for the stormwater infrastructure system. So our preliminary comprehensive plan, we're going to recommend 3 main things, which is the addition of green infrastructure throughout the city in order to provide improved water retention, as well as engage the community in what infrastructure can look like versus the gray infrastructure that they see today. We're also going to include the addition of artificial intelligence and machine learning interventions in order to monitor the present infrastructure that's already there, as well as any new infrastructure. And we are also going to use it to assist in predicting future problems. We also want to focus on creating an asset management plan to help Madisonville track the utility services that it already provides, as some of the documents are extremely old and have been lost. And we also want an inclusion of a capital improvements plan for future development of the city. So our hopes are that the ENDEAVR partnership with Madisonville will continue after the semester, and that the students in the future can take what we've done and use it as a stepping stone and build off of while working on their ENDEAVR and capstone projects. Our comprehensive plan is comprehensive plan and bioswales are the immediate actions that we're taking, but we're hoping that students can find different ways to address the problems that Madisonville has. That's it. Thank you.